Hello everyone, how's everybody doing? I hope you're doing fine. I want to remind everyone that we have the seventh Rational Physics Conference in Boris, Sweden, and you can sign up for it. This is the picture. That's where Boris is, in the middle of nowhere. Hopefully some people come and participate. And you can sign up either through the Seventh Rational Physics Conference site in Facebook, or you can also sign up through my Patreon site, send me a message or whatever. Okay. So we hope to see people there. It's going to be on the 8th of June. And, you may want to make your reservations early if you plan to attend. Okay. Second issue I want to mention is that, yeah, the rational scientific method closed down. I'm sorry to see it go. We've had it open for several years, maybe 6 or 7 years, I guess. I don't remember anymore. But it was up for a while, and yeah, it was shut down due to health reasons of the owner. And so I had to make some changes. And so anyone who wants to make comments to the videos or ask questions, I ask that you go to the Patreon site, and that's where I'm going to be loading the videos as well as answering questions if applicable. I don't answer all the questions because, as I'm going to discuss today, a lot of the questions are show that the person hasn't understood what this site is about. And that's something I really want to clarify today to some degree. People ask questions, and the same questions that they ask give me an idea that they haven't done a minimum of research or looked into what the site is about. That's unfortunate. And, I want to make sure that I notify people of what this site is about so they don't waste their time. You know, at the same, in the same vein, I don't want to waste my time reading some of the comments to find out this person hasn't even done a minimum of research on it. Sometimes, it's like a hit and run. People come, look 2, 3 minutes into the video, says, "Oh, I know what all this is about," and they just put a comment or even a question, and then they leave, and they're wasting their time. They're wasting my time. We don't want to do that. We want to make sure that people um, come here because they want to hear and learn something new. And most people think that this is just business as usual. I don't know how to tell them that this is not business as usual. And people say, well, everybody thinks they've got something new. You know, everybody thinks he's got a theory that's different than all the rest, that he discovered something new. No, this is genuinely different. And that's why we call it the rational scientific method, rational science. We put that word rational in front because we're saying that what we've done in the last 400 years, since the so-called scientific revolution in the 17th century to contemporary days, was not science. I mean, some people did science here and there accidentally because they were trying to really get to the bottom of things. But most people did something else. They did experiments and they did math. Experiments were designed primarily to see if, some technology could be derived and the guy could make some money. And the math was just a description of something that the mathematicians, the researchers, the scholars who did the brain work on this, uh, they were trying to figure out what that invisible stuff was. But since they couldn't, they simply described it. And that's all that mathematics does. So this side is different. It's different because, um, first of all, I can just enumerate and list the things that are different from rational science to what has been done until today. And the first one I'm going to mention is that in science we do not do experiments. And I'm not facetious. I'm being honest here. So if you think science is about doing experiments and this offends you, well, you came to the wrong site. In science, we do not use math. We have no purpose whatsoever for math. Today, if we burn all books of math on planet Earth and we wipe out all the equations that we've ever discovered, we will not be affecting in even a teensy-peensy bit science. We will not affect it at all. In science, we don't do predictions. That's astrology, palm reading. In science, we do not falsify anything. We do not falsify theories. We do not verify them. We do not observe. Blind men can be scientists. So we do not observe, we do not falsify, we do not prove theories, we do not use math, we do not do experiments. Those are primarily the ones. So if this shocks you, and you say, I'm not going to listen to this guy, yeah, you came to the wrong side. I want to make sure that you don't waste your time. Okay? And so some people might be curious and they say, well, Bill, what kind of science do you do? You're not doing math, you don't do experiments. So, how am I going to be sure? How will I know that your theory is correct or that any theory is correct? Well, in science, we don't. We don't know that any theory is correct. And we don't care about knowing which theory is correct. Correct, incorrect, right, wrong, false, true. None of that has anything to do with science. That's personal belief. When someone says, oh, they've proven this or they've proven that, all they're saying is they believe in what they heard or saw. That's all they're saying. And so we don't care about opinions. There are no observers, no personal opinions in science. Okay? And mathematics can only describe. That's the only purpose of mathematics. Mathematics is a language. It's a tool. What is an equation? An equation is a description. You have a car. It runs. You can time it. You can measure how fast it runs. You can put that in an equation. You can even predict. You can say, look, the car's running at 50 miles per hour in 1 hour. If all else being equal, in 1 hour it's going to be 50 miles down the road. So you can predict. And none of that has anything to do with science. None of it. Imagine I give you a chair and you say, okay, I'm going to mathematize this. It's got 4 legs, 1 backrest, seat, maybe 2 armrests. So did you do science because you described it mathematically? Science, according to this site, is rational explanations. You must explain something. In physics, we have to explain a phenomenon. You have to explain something that happened, a physical phenomenon. You have to explain the mechanism. You have to explain the cause. Mathematics has no purpose whatsoever for that goal. We cannot use mathematics in any way, shape, or form to explain a mechanism. A mechanism, physical mechanism, you explain it with objects. You make a movie, put it on the screen for everybody to see. They see it on the big screen, and they can understand the mechanism just by watching the screen. Now, maybe in the background you can explain, clarify things, of course. But the point here is that I don't need any equations. I don't need to put any equations on the board. I don't need to know how much force, how much energy, how much mass, how much time. I don't need to know any of that to understand a mechanism. And you might say, well, Bill, this is a different type of science. What's the purpose of your science? Well, here we are, 400 years after the 17th century scientific revolution. Big words. No revolution whatsoever, just a minor change, a tweak to what Aristotle and Plato did 2,000 years earlier. And here we are, what is it, 21st century? Hopefully I haven't time traveled. Here we are in the 21st century. Not a single individual working at any university on planet Earth or any of the major think tanks such as CERN, the Large Hadron Collider, LIGO, what was the other day, the EHT, Event Horizon Telescope, Polar Aberration. None of these people, there's not one individual in any of those organizations that can tell you something as simple as how a magnet attracts another. They can't tell you how this magic is done by Mother Nature. Here you have a magnet, and it just sticks to another. What do we have here? How difficult can this be? I mean, this is, Jesus, this requires what? Rocket science? We need rocket science and math to figure this out. We have two chunks of metal, two pieces of metal. And no one on planet Earth can tell you why that happens. They cannot explain the mechanism, the physical mechanism. And I'll tell you right up front here, the only way you're ever going to figure this out is to figure out what invisible thing is there between these two magnets. There's something there. You can feel it pulling on you, and when you put them upside, you can't even put them together. He goes up, he doesn't want to go to the one in front. How difficult can it be? Two pieces of metal. That's it. That's the whole system. We take everything out of the universe. We just leave these two magnets there. And they attract. Not one person on planet Earth working at any university, at any think tank, on any department of physics, big word there, really mathematical physics, not one person can tell you the magic. In fact, they asked Richard Feynman to explain how a magnet attracts another, famous BBC interview in the 70s, I think it was. And he finally said, well, there's a force there. But if you really want to know, you got to go to college, and we can tell you, at a higher level. He couldn't tell you. And nobody can. Not one person on planet Earth working at any major institution, think tank, college, whatever you want to call it, can tell you how those two magnets attract each other or repel each other. Not one person in those same institutions can tell you why this pen falls down. I mean, I wish it would fall to the sky, but it always falls. Let's see if I can catch it here. Huh? It still fell down. Falls down. How does it do it? How does Mother Nature do this magic? Not one person can tell you. And what I'm talking about is the physical mechanism. Is something pushing the pen downwards? Something pushing the two magnets together? Why, when we turn them around, these same things push them apart? What happened? Look how simple it is. Here, here they pull, right? And all I need to do is just turn it around, right? And now suddenly they push each other away. Something happened in there, in between those two magnets. Now, some people say, well, we have push from the outside. No way, absolutely no way. You can feel that thing, right there. There's something preventing the two magnets coming together. Right there, that's it. It's something between the two magnets. Don't tell me that the walls of the room have something to do with this. No way. It's not the air. It's not something outside of the magnets. It's between the two magnets. And anyone who says differently is just an irrational individual. You can't, after so many centuries, continue to insist that you can do this with pressure. Those are just people who want to insist on particles and waves because they're not creative people. They can't think of a mechanism. And the same with gravity. No, not one of these people can tell you what light is. For example, you have experiments such as the slit experiment. Not one person can tell you how that's done rationally. I mean, they have magical explanations, where particles just do this and that, and they introduce virtual particles, which are, ad hoc particles to get their explanation through. Yeah, I mean, everybody can do it with magic. I can too. The issue is, not one of them can do it. Not a single person on planet Earth can draw for you an atom. I'm not talking about uranium atom, 92, atomic number 92, 92 protons, 92 electrons, big atom. No, I'm talking about the hydrogen atom. One proton, one electron, no neutrons. More as simple as you want it, In fact, today I did a little research. I just put the word atom on Google, the images, and this is what I got. Okay. So is that the atom? Well, when you point this out to the mathematical club, they say, well, that's not the atom. That was the old atom. That was the original atom that Niels Bohr came up with. The planetary atom. But it turns out that this is what you'll find. You'll find it all over the internet. And you might say, well, that's not the real atom. Well, how come everybody draws the same thing? I mean, don't take my word for it. Just put the word atom, look it up from pictures, images, right? And you'll find images similar to these. And they might say, well, the atom is a little more complicated. Well, what do you mean more complicated? Well, the atom actually, the electron, we don't know where it is around the proton. It could be anywhere in there, so it's very complicated. I said, well, it doesn't matter, because, I mean, what you're saying essentially is that there's an electron and a proton, one ball next to another ball, somewhere around that center ball. So you're still talking about two little balls, and this shows those two little balls, essentially. I mean, here you have more complex atoms. You have atoms with 3 or 4 or 5 electrons, but, the hydrogen atom would be one of these, with just one of these balls in the center with a little ball going around it. So that's the atom. So they're still using the planetary atom. In fact, if you look there at the second one at the bottom, the one in the middle, it says electron released. That's how they show ionization. And the one on the right next to it, that's above the word plasma, it shows the same thing. What is plasma according to everybody and their mother out there? Well, it's just a proton that lost an electron, and the electron is part of the soup, this thing that's in the floating in there in whatever chamber you have. And it's known as plasma, a mixture of free electrons with protons and everything dancing around. In fact, here I have an even better picture. Here's plasma. Here you have the red ones are supposedly the main atom, or you can call them the proton. I mean, if these are hydrogen atoms, the blue ones represent the electrons, and the red ones represent the protons. And the electrons are let loose, they fly around, and you have plasma. That's what these people call plasma. So whether you use ionization, whether you talk about plasma, or whether you talk about, electricity, what is electricity? According to the official version, quantum version, the mathematical physics version. Well, it's the flow of electron beads. An electron, it goes from atom to atom all the way to the end. That's what it is, the flow of electrons. That's how it's defined today. And I'm not worried about that. I'm worried about what atom are you going to start using? What does your atom look like before you explain anything? Before you explain ionization, plasma, electricity, I don't care. Show me your atom. Not one person can draw an atom. And I'll tell you why. Because if we look at this atom here, where is it? I think it was this one. If you look at that, you have to tell me what is between the electron, little ball, right, and the proton. What is that white stuff that's between them? All of these, see, are separated by some white stuff, undefined white stuff. And the question is, what is that white stuff? That's what you got to identify. That's the famous ether we've been talking about. That's the famous space that is not so empty that we've been talking about. Some people like to call it a fabric. Others like to call it a field. They use all these fancy words. Not one of them represents a physical object. I need to know what keeps the electron ball from flying away. And then because we can always explain electricity, once we understand that part, we can explain electricity, ionization, plasma, we can explain all that stuff. But what you need to start out with is tell me what the white stuff is. I need to know what that white stuff is. That's the mystery. All the rest we can all understand. We need to know what the white stuff is. That space, that fabric, that mysterious field, and all these other fancy words that they use to describe it. Okay, that's the part that we're missing. And until you can get that done, you don't have a theory. And that's what we do here. That's where we differ. We're going to do this mechanically. We're going to explain physics mechanically so that you can see with your own eyes what I'm proposing. Now, it doesn't mean that you're going to believe it. We're not here to preach. This is not Sunday school. Pastor Bill is not on duty today. What we have here is I'm going to explain a mechanism to you, and the idea is for you to understand the mechanism, to visualize it and say, okay, I understand what he's proposing. Whether you believe it or not, that's your personal opinion. The idea is for you to understand, not to believe. And that's very hard to get across for people, because people have this idea that you must prove theories by introducing evidence. In science, we do not introduce evidence, not at all. Evidence is what a prosecutor introduces to persuade, convince, recruit the jury, the juror, the jury. The purpose of evidence is to persuade, not to explain. I mean, there's nothing wrong with introducing evidence to say, look, let me tell you why I believe this or that, because see, here I see some evidence. But when I do that, I am trying to persuade. I'm trying to convince. I'm trying to make you believe the way I believe. And that's called religion. That's called religion. In science, we explain objectively, we explain a mechanism, and then we're done with science. What continues after that is religion. Okay? So what is this site about? Well, here we have rational science, and this is the general picture of what we have here. And we're saying that science is rational explanations. That's what science is. It's divided into physics and philosophy. Here we're concerned with physics, and we do physics with objects. We're trying to figure out causes and mechanism. And science is objective. Why isn't math part of science? Well, it's not part of science because in math we do not explain. In math we describe. And what did I just say? Science is rational explanations. If you're not explaining, you're not doing science. Mathematics does not explain, mathematics describes. That's why math is not a part of science. And I don't care what all the mathematicians on earth did. I don't care what tradition tells you, what you learned in school, what you did in the last 400 years since the revolution, scientific revolution. Say, well, you know, that's what science has always meant, what physics has always meant. We don't care about any of that. I'm saying here that science is about explaining. I need to explain how a magnet attracts another. I need to explain what gravity is. I need to explain what electricity is. I need to explain how an atom works. For that, I need to show you a picture of my atom. Whether it's Mother Nature's atom, I don't know. But I'm going to show you my atom, the one that I think Mother Nature has. You don't have to believe in it. You just have to understand the mechanism that I'm proposing. Okay? And so all these things, today we have no explanations for them. So should I continue to follow tradition? Because that's what we've done for the last 400 years, and all these scientists can't be wrong. Well, they're not wrong because they're not even right. They're not even in the ballpark. Not one of them can explain a simple mechanism such as gravity or as magnetism, or electricity for that matter, because to explain electricity, they would have to use the planetary model, and for that they would have to tell me what keeps the electron tied to the proton. And they can't do that. They have no way of doing it except through concepts, through abstract concepts. They can't show me the physical entity that mediates. That's the issue. And that's what we're missing for the last 400 years. So yeah, the science that they have today is no good for me because I can't go to a book, open it up, or watch a movie and find out how they're doing the magic, how they're doing the mechanism. That's the problem. We have no mechanisms today. And of course, what the mathematicians have done in the end is say, well, you know, we can't understand how Mother Nature runs her universe. We can only describe it. So they turn science into descriptions. And when you go out there and say, well, how about explanation? Oh, that's philosophy. That's metaphysics. That's semantics. That's belief. That's who knows what. Science, physics, that's the equation. No way. No way. I need to know how a magnet attracts another. I need to see that mechanism. And that's what we do here. So what am I proposing? Well, here I'll give you an idea, a simple idea. You know, if someone asks you something simple, something very simple, says, how did the window break? And you say, well, you know, I threw a brick through the window. That's how it broke. Do I use the word energy? Do I need to take a high-level physics course or mathematics course at the university to find out how a window broke? Or how a farmer pulls on a donkey? No, I just show you the movie or the picture, or I explain to you that, you know, the farmer tied a rope around the neck of the donkey, is pulling on the donkey through the rope. And you watch the movie and you say, okay, I understand how the donkey came forward. I understand how the window broke. You threw, you know, a brick through the window. In fact, here, let's see if you can figure out how Felix the cat here, you know, if you can figure out how he broke the window. There it goes, and it starts. So did everybody figure it out? Was it too difficult? Did you open your math books to figure out how the window broke? I mean, we have two objects. Three, if you consider you know, Felix as well. But we have a brick, we have a window pane, glass. The brick hits the window and breaks it. That's how it broke. That's how you would explain it mechanically. That's the explanation. Do you have to take a course in math to explain that? And so this is the issue. The issue is here we have two magnets, and this is no different than what you just saw with the brick going through the window. There it is. This two objects, just like the other one. The other one was a stone or a brick and a window. Here we have two pieces of metal. Do you need to take a high-level course in math to figure this out? Do you need any math? Do you need to use words such as time? Do you need to use words such as field to explain this? Energy? Mass? No. You just say, this is the mechanism, the invisible mechanism that Mother Nature uses. For that, you absolutely need to make an assumption about the mediator that's between those two magnets. That's what you got to figure out. That's the trick. That's how you figure out the magic trick that Mother Nature is playing on you, the trick she's doing. Okay? And this is the issue. We try to explain it mechanically. And that offends a lot of people because they're not used to thinking in these terms. They say, well, where's the equation? Let me run an experiment. How many experiments have you done? Has anyone verified or falsified your theory? I just want you to look at the mechanism, say, does this mechanism explain what I'm trying to explain? That's all. And if you understand the mechanism, we're done. We're done with the scientific part. What continues then after that, your belief, whether you believe in the theory or not, is your personal problem. I don't even want to hear it. Okay, so here, let's move on. Here's my version of light. Now look how difficult that is. I'm saying light is a torsion of a rope. We have a rope that binds any two atoms in the universe, and what it does is it twirls around, much higher speed than this, by the way, and what it does is the signal that arrives at the other atom is what we call light. So light is the torquing of a DNA-like, rope-like twine pair of threads. Okay, so we make an assumption. Okay, we're going to say, let us assume all atoms in the universe are interconnected by a twine pair of threads, and when the atom expands and contracts, consistent with the so-called quantum jump, it torques the rope, sends a signal to the other atom. That's it. That's how simple it is. Simple and symmetric. Rope is symmetric. Okay? Something they've been looking for a long time, but you present this to them, they say, can't be. Why? You were looking for simple and symmetric, you got simple and symmetric, right? Okay, that's light. What does our atom look like? Okay, here's the atom. It's built with those same ropes. In other words, you have two threads. One of the threads goes straight through the center of the atom. The other one goes around. We call it and builds the electron shell. And this is what an atom more or less looks like that you'll see coming up here. Okay, that's it pretty much. You see the ropes end at the electron shell, the red curved line. Okay, so very simple. And obviously this is a cross section. This is not a 3D, but you have to think of that as a sphere, almost a perfect sphere, at its level, because it's built with every rope converging upon our atom from every atom in the universe. So all these threads twine around our little atom and construct it. Okay, so we're being consistent with the rope model. In other words, we're saying the same rope that is light turns into the atom. They're not two separate things like in mathematical physics. Here you have the atom and here you have energy. Whatever energy is, and that energy is that photon, which is light, which is, massless and all this other stuff. Little particles that go and hit your eye one way. See, the rope is two ways. The torsion goes in both directions. Okay. How do we explain with this magnetic attraction? Well, here you have a little picture of the two little men. And again, I'm not asking you to believe anything here. I'm just saying, do you understand the mechanism that I'm proposing? I'm saying the one on the left is the mechanism of attraction. The one on the right is the mechanism of repulsion. When two magnets are facing, and I'm going to show that in a second, but when two magnets are facing in the same direction, north, south, the south end of one it faces the north of the other, you have situation one, the one on the left. The threads move around. These threads come from the same ropes that interconnect atoms. And all I'm trying to tell you here, you don't have to believe any of this. All I'm saying is, what we're talking about here is a mechanism. Does the mechanism on the left produce attraction? That's the question. That's the only question. Don't ask, what are threads made out of? And it's not even relevant at this point. This point, we're looking at the mechanism. Does the mechanism on the left produce attraction? Does the mechanism on the right, when you turn the magnet around and it faces against the other one, if the threads hit against each other, does that produce repulsion? Does it produce push? So you have pull and push. And all we're talking about here is mechanisms. So before we can get into what is the nature, do ropes go through each other, and all this other questions that people have, first you got to answer the question. And the question is, do these two mechanisms produce attraction and repulsion? That's the only question you got to answer. And it's a yes or a no. It's black or white. Okay? And so how does this work? Well, let's get the right one here. Here, the magnets, and whether you turn them around or not, you will see the same thing. A magnet is divided not into north and south, like in traditional mathematical physics. A magnet is divided into top half and bottom half. We have the top half are the blue or violet ones there. The ones on the bottom, the green ones, those are the bottom half. If you turn a magnet around, it still stays south facing north and nothing changes. Both are facing clockwise, the threads on the top, and vice versa on the bottom. Now when you turn them in the 180 degrees, one of them, now you have clockwise against counterclockwise. Now they hit each other and they push each other away. So you have clockwise and clockwise versus clockwise against counterclockwise. And that's something Mother Nature does understand. So again, what I'm saying here is that a magnet is divided into top and bottom. Okay, not into north and south as has always been said under the rope model. And when the threads go clockwise, and both of them go clockwise, then the top pulls on top and the bottom pulls on the bottom. You turn it around, nothing changes because you still have the same situation clockwise and counterclockwise on the bottom. When you turn it in the other direction, now you have counterclockwise facing clockwise. And again, in the same thing at the bottom. Okay? And so that's what the mechanism is for attraction and repulsion. And again, we're talking about mechanisms. Okay? You know, people say, what are the threads made of? And they say, do they do this? Do they? Answer the question. The question is, does the mechanism that I just explained produce attraction here and repulsion there? That's the only question you got to answer right now. And you can't move on to another question until you concede that. And the next question is my turn to ask question. Can quantum do this with particles? How do they produce attraction, repulsion with particles? That's where we're going to have a nice, beating up of a nice roasting of quantum mechanics. Because if quantum can't explain it, then I can't allow you to go back to quantum. You can't say, well, your rope model doesn't work, so I'm going to go back to quantum. No, quantum cannot explain it. That's the point. The point is, I have a mechanism, quantum doesn't, a physical mechanism. That's the point. Okay, let's move on. Here we have gravity. Okay, see if I can get it up there. Okay, here you have all the atoms in the universe are interconnected. That's on the upper left. On the bottom, you see the simplest of mechanisms. You see two atoms connected by a rope-like mechanism, right? Or a rope-like entity, I'm sorry. And that's the basic system. You can see it's simple. You can see that it's symmetric. How do we explain gravity with this? Well, there you see it, the acceleration of gravity. You have one atom on the cylinder, upper right hand corner, and you have five atoms, I'm sorry, on the cube. As long as they're all on the same line, it's like all these atoms, 2 through 5, don't exist. The tug of war is between 6 and 1. It's like the others are just touching it or hanging on to it. They don't intervene because they're all on the same axis. As the cylinder moves closer to the cube, all the ropes that interconnect those atoms go out of alignment. In other words, now each one pulls independently. Now the cylinder is feeling each atom separately. And at the bottom, you can see the inverse square law. When two objects are very far away, all the ropes form like a single coaxial. As they approach each other, we see why we have the acceleration of gravity. We see the ropes fanning out and pulling ever faster and faster and faster, consistent with the tug of gravity. And if you didn't catch it, here's I have another little picture here that might give you an idea what I'm talking about here. If two guys are pulling on a rope, doing a tug of war, and four guys right there on the top, right, just put their hands on the rope, neither guy feels those four people. They don't feel them because they're all on the same axis. It's like, they don't exist. They could be touching the rope or whatever. The tug of war is between the two end guys. On the other hand, one guy has to pull against those five people. Now we have a difference. Now this guy feels the tug of war, the tug of five people. And that's essentially what I'm saying as far as gravity is concerned. And there you see a piece of Newton's gravitational equation, m1 times mass 2 divided by the distance that separates them squared. Okay? That's essentially the mechanism that I'm proposing for gravity. And we do this with the rope, the same mechanism. No particles, no waves, no ether, none of that nonsense, okay? And and just one more thing on gravity that you should be aware of, and that's here we have Mr. Richard Muller. He's a professor at Berkeley, and he says, so for example, if you have the Earth, there's a big mass here, and you have you with your little mass here, and there you see the little drawing with a little man sitting on top of the mass known as the Earth. That's what he was explaining. And he says, every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Well, he just described, as far as I'm concerned, he described every atom being interconnected. You're connected to every atom on Earth, not on the surface only, also those going right through the center of the Earth. Every atom on Earth is pulling on you. Think about that. The only way you can explain it physically is if they're connected. They're all connected. There's no other way. You can't do this with, I'm going to send little balls. I'm going to send particles. Or I'm going to send waves. They discovered gravity waves the other day, so they claim. No, you can't do it. What gravity wave is a little atom in the center of the Earth, or somewhere in the, near the center, or between the center and the surface of the Earth. What wave is that little atom sending each one of the atoms in my body? What particle is it? I mean, I can't imagine poor God trying to manage every little particle from every atom that comprises the Earth. It's throwing particles at me. Just the accounting of one planet is just outrageous. No, it's much simpler to explain this by saying every atom is interconnected. We're done. That's how simple it is. Now, it doesn't mean, again, you have to believe. I'm just explaining the mechanism. Okay, I'm explaining how two objects approach each other and the ropes fan out. That explains the acceleration of gravity. A guy who jumps from an airplane, hopefully with a parachute. But let's say he jumps without a parachute. Okay, so you know that he's going to accelerate as he hits the earth. Why? Well, again, as he approaches the earth, the ropes fan out. You know, the guy's doing this. The ropes that are attached from his body to every atom on earth, they are opening up and they're pulling him ever faster because every rope pulls independently. Far away, gravity is weak because it acts like a single coaxial. As it approaches, the ropes pull faster and faster and faster, and now we have an explanation for the square of the distance. Okay. That's gravity. Let's see if we can move on here. Oh, by the way, this is the why the moon doesn't fly out of the solar system. Every atom from the moon is attached to every atom on Earth, just like you're attached to every atom on Earth. And here we have another one. Where is it? Here you have the left-hand side is the mysterious thing that we can't see, gravity. You know how the Earth goes around the sun. The second one is very simple. What you have is every atom on Earth connected to every atom of the sun by some rope-like mechanism, DNA-like mechanism, agent, mediator. And now we can see why the Earth doesn't go flying out of the solar system. In the first case, you don't see it and you say, oh man, that's magic. But all you have is two objects. And we know, like Mr. Muller just explained, that every atom on Earth is connected to every atom of you, and every atom on Earth is connected to every atom of the sun. What is he describing? He's describing scenario number 2, the one on the right. He's saying that every atom is connected, and if they're connected and the Earth doesn't fly out of the solar system, well, what should you conclude? Shouldn't you conclude that maybe there's some kind of mediator that we can't see, that's all? That we just can't see it, but it's there? Well, there it is. It's the what I call the electromagnetic ropes that interconnect any two atoms in a universe. Okay? Now, I'm not saying you should believe. I'm saying, do you understand what I'm proposing? Because people say, well, I don't believe in ropes. And I don't think ropes is what does it. I'm not asking you to believe. I'm asking you, does this explain the acceleration of gravity? In other words, if the Earth were to fall towards the sun, won't it accelerate and get faster and faster and faster as it approaches the sun? Of course. You know, we know this also from people who fall from the sky. You know, parachutists, why do they fall to the sky? Why is there an acceleration? Because every atom on Earth is connected to every atom of that parachutist. That's why. And you may not like it. That's what the equations tell you. The fact that they insist on particles and waves, one-way particles and one-way wave. You know, here's the atom in the center of the Earth throwing a particle at you, and somehow that particle attracts you. Now, what sense does it make? And all I'm saying, they don't have a mechanism. In fact, the mechanism is a mathematical mechanism. They say the atom is throwing negative momentum to you. So you're receiving all these vibes, this negative momentum. That means, think of negative momentum as negative motion. It's throwing negative motion at you. Instead of pushing the dog away, the rock delivers negative motion and the poor dog moves towards you. That's what they're saying. So I'm saying that their mechanism doesn't work except through magic. My mechanism is direct. It's a physical mechanism. You don't have to believe in it, but you know, all I'm asking is, does it explain the mechanism? And it's a yes or no question. You don't have to go into what is the rope made out of, how many ropes are there, you know, are they odd or even? those are questions that are not pertinent at this moment. Right now we're looking at mechanisms only. And we're trying to compare the mechanism of the rope model against, what mathematical physics has to offer. You have general relativity saying gravity, oh, that's warp space, the warp canvas. Why should you accept that one? Any better? Or negative momentum from quantum mechanics, it doesn't even have the graviton in its standard model because it can't figure out gravity with particles. So here we have a mechanism. Okay, so that's the point. The point is that I explain mechanisms here. I'm trying to visualize how Mother Nature does her magic tricks. Okay, here's electricity for you. Okay, what is electricity? Also done with the threads and the ropes. Each thread is released when the serpentine, as I call them, the row of atoms, twirls. You have electric current towards your eyes, and you have the magnetic field towards 90 degrees to it, in this case, towards the left. Okay, so here's in reverse, but what we're showing here is that as the serpentine turns, the row of atoms turns, it releases threads. The threads are going to form what is called the magnetic field. As the thing turns around, the magnetic field travels at exactly 90 degrees to the twirl of the electron shells that are bound to each other in this case. And the electric current goes into your eyes. In other words, electricity is not the flow of current. It's a what I call serpentine twirling in place. And by doing so, it releases threads. It compels the threads to sweep around, and you have here I only show one cross section of the field. What you have to look at here is countless threads, walls of threads just moving around that line of atoms. It's a little more complex than that. You got to think of this as molecules, not as atoms. Here I show it with individual atoms just so that you get the sense of what I'm trying to tell you here. The way this really works is that, like in the case of iron, what you have is molecules which are bound to each other, also through the rope, through a physical mediator. They twirl, and when they twirl, they swing countless ropes around themselves. Threads. And the threads are going to form the magnetic field. And for sure, when you have that mechanism, they do travel, the threads will travel at 90 degrees to the flow of current. And this at least explains or justifies why, magnetism goes 90 degrees to electricity. Or the other day we were discussing Maxwell's laws. In fact, I'll put it up here because it does lead into that. Here are Maxwell's 4 equations. Okay, and what do these equations mean in physical terms? Well, they mean the following. Just to summarize here, what you have here is the 4 equations. The 2 top ones are the 1 and 2, and the 2 bottom ones are the 3 and 4. The first equation just says that electric charges, you could call them. I mean, if we're going to talk about charges, they flow from out of positive and go into the negative. That's what the first equation, Maxwell's equation, relates to. The second one there, where you see Carl Gauss on the upper right, there are no magnetic monopoles. You need 2 poles in magnetism. Okay. The third one, where you see Mr. Faraday, it can induce an electric current by shoving a magnet through a coil, a live coil. And the fourth one, you have a flow of current, assuming that's what current is, and what you have is the magnetic field around it. Well, if you look at that last one, that's exactly what I explained just now. You have current running from left to right. And instead of thinking of little balls flowing from atom to atom, electron balls, what you have is the whole thing twirling in place. What you have is the molecules just twirling in situ. And by doing so, they swing all these threads around themselves. And the threads are the yellow arrows there. They're going around the wire. They go, in fact, outside of the wire. And these threads form the magnetic field. As you can see, the magnetic field travels 90 degrees to the flow of current. And we use the word flow when there is no flow. What we have is a serpentine twirling in place. That's what I'm saying that electricity is. Electricity, a bunch of molecules which are attached to each other. Atom to atom or molecule to molecule. They twirl in place. By doing so, they swing countless threads around themselves, and those will form the magnetic field. So that's the mechanism. Again, we're talking about mechanisms, okay? And again, people say, well, what are these threads? What are these ropes? Where do they come from? They have lots of questions. But they're irrelevant questions at this point. They're irrelevant questions at this point. We have to start with kindergarten stuff. We need to learn the kindergarten, what I'm proposing first, before we can get into more sophisticated questions. And in fact, there's something that precedes that, and that's the fact that people want to skip and they just say, well, I want to do physics. I don't want to do semantics. I don't want to do philosophy. I don't want to do metaphysics. We need to define terms. We need to know what an object is. We need to know what we mean by the word exist. Physics is the science of existence. Physics only deals with what exists, and nobody has ever defined the word exist. You have atheists and theists running around in circles saying, well, God exists. No, God doesn't exist. Why? Because they never defined the word exist, among others. They haven't defined what an object is either. We don't know if God is an object or a concept. I mean, I think I have one here. Let's see if we can get, here we have them. Here's the top one. That's God of the Old Testament. Okay? And on the left-hand side, you'll find, upper left-hand side here, you find the creator. This is the guy who creates the universe, right? He goes into it with his magic wand or spear in this case. And on the right side, upper right side, you have the burning bush or the flaming bush. Okay? Those are physical objects. On the bottom, you have the New Testament. In the New Testament, they converted God into a concept. They morphed him. God is love. God is spirit. John says God is spirit, And so what is God? Is God an object or is God a concept? And, these are questions you need to resolve before you get into a discussion about, does God exist? Can we talk about the existence of God? No, first we got to settle what we mean by object, what we mean by exist. And so these words have to be settled before we get into physics. The issues of existence are issues of physics. Anyone who touches the word exist has crossed the line into physics, whether he knows it or not, if he's going to talk scientifically about it. And if we're going to talk about mechanisms, you better know what an object is and also what you mean by exist. Do you know what the word location means? Do you know what the word motion means? These are words that we need to define. And people want to skip all this stuff and they just want to go into, what does the rope do here? And no, you need to start at kindergarten level. You got to understand what an object is. And it takes people 2 years to know what an object is sometimes. I mean, just off the top of my head, I ask people, well, is a hologram an object? Is an angel an object? Is God an object? Is a tri-bar an object? And people start, well, I don't know. That one, I don't know. Let me think. If you can't answer those questions black or white right off the top of your head, you don't know enough kindergarten stuff to tackle the rope model. And again, maybe you came to the wrong site. You don't have to believe me. I'm just saying, if we're going to talk sense, if we're going to talk rationally here, you need to define the words that the foundations of physics. And that includes words such as object, location, distance, motion, exist. These are dimension. You need to know what these words mean exactly. You should have no doubt. Then you can try to understand, the theory, and then you can find, when you get to college, finally you can ask questions like, well, how is it that the ropes manage to go through each other? Do they go through each other? Do they stretch? Do they, how do they do that magic? Then you can ask those questions. One question I always ask people when they ask me, do the ropes go through each other? Which I never answer here. It's in my book. And people say, oh, you just want me to buy your book. No, that's not the point. The point is that people want to skip the kindergarten stuff and they just want to go directly into college. And what I'm saying is, like in the case of the ropes, do you know what touch means? I mean, before you can cut across two things, here, let me see if I can do it with this. Just imagine this. Before this, you can cut across that, right? Hopefully it's got to touch it first. Then it can go across, right? So I ask them, what does touch mean? And they have no clue. They never even thought about it. They never thought touch was such an important word. And so I'd say, okay, touch is zero distance. That's touch. That's the scientific definition of touch. Zero distance. But the problem with zero distance is you converted two objects into one, which is the problem of ether. You have these little balls, I don't have one. Here. Here's a ball. Ether ball, right? Here's another ether ball, different color. So they each have a surface. Something is separating these two things. Something is contouring, encapsulating these two objects. I need to know what that object is. Otherwise, you wouldn't have two balls. What you would have is a single block of ether and nothing moving in it. You see the point? And if you're going to have balls, you got to tell me not what the balls are. I don't care about the balls. Tell me what contours and what encapsulate them. Is that stuff infinite? Which is what we were discussing. And what we will continue discussing next time around. What is it? Sunday? So I'll see you then, and we'll continue with this, and I'll pick up where I left off. But today I thought I needed to clarify for lots of people out there that, don't waste your time if you come with the old notion of what science is. This is a new site, and here we're going to be doing mechanisms, and it's going to hurt your brain if you come from, if you've been brainwashed with what science is according to the mathematical physicists. This is a different site. So we're going to talk mechanisms here so that you can visualize how things are done according to the rope model. So with that, I'll see you on Sunday, same time, same station. We'll see you then. Bye-bye.